the summer. Let's just jump in with our exponent rules. Do you guys remember if you are multiplying? Now I kept this generic in terms of variables, but we could do numbers if it helped. If I said like, ooh, I don't want to highlight it right now. Let's say I told you 2 to the 5th times 2 to the 4th. What would that turn into? What would you do with those exponents? Add them. So it becomes 2 to the 9th. So if they're multiplied, and we call it the base is written each time, you add those. So that's a to the n plus n power. And that table is kind of set up in 2 columns. If you want to put an example in the right-hand column, you can. Alright, what if I said 2 to the 5th power to the 4th? What does that become?
You multiply 5 and 4.
So that becomes 2 to the 20th. So when we have that power to the power, we multiply those exponents. The third rule. So if I said like 3x squared, what would that become? Close. Yeah, because it means you have 2 of them, right? And 3 times 3 would give us a 9. So you end up squaring both of them. You square the 3 and you square the x. So if things in the parentheses are multiplied together, you can take that exponent to each of them. And the same is true if they were set up like a division, which I think I have as a separate rule on here a little bit further down. If you are dividing, what do you do with your exponents? So if we have like x to the 7th over x squared, becomes an x to the 5th. Rule number 5 is very similar to rule number 3. In a fraction, exponent can go to the top and the bottom. So for example, if you said 2/3 to the 3rd, you have to do a 2 to the 3rd and a 3 to the 3rd. Are we familiar with this stuff at all? Do you kind of remember seeing it in the past? Couple other things to do with our exponents. What does anything to the 0 power become? So anything to the 0 becomes 1. It's like saying you have none of them. So we just get a 1 in its place. And what does a negative exponent mean? I said like 2 to the negative 3 power.
Oh, it's
so negatives change floors, moves it to the denominator. And then once you move it, that exponent becomes positive.
Which also goes backwards too.
So if you have a negative on the denominator, it would move up to the top and be a positive exponent.
But it needs to be positive, correct?
Yes,
Finished.
proper notation is all positive exponents. Any questions so far? Alright, so let's do a few examples before we look at more definitions. So you might have to switch to your notebook paper, or if you write small, there might be room on the back of this handout. I didn't type up all my examples for you. Let's just see if we can simplify some expressions with exponents. M to the sixth times m to the eighth. Just add those exponents. So again, these you can just add on the back of that handout or on another sheet of paper if you want to use your notebook. I didn't type those examples. What if we have several things to multiply?
Do the first two first.
Okay. So there's really several different options for how to do it. You could think of it as multiplying two at a time. Negative 5 times 6.
5 to the 7.
Because we're adding those exponents. And so then if we multiply,
90 over to 8.
because remember, if there's no exponent written, what do we assume it is? A 1. Okay, I'm going to put a couple up here and I want you guys to try them. So just take a couple minutes and see if you can figure out what these are. Maybe you figured them out, maybe you didn't. So C is kind of involving a couple different rules. If you have a power to a power, what do we do with those exponents? Multiply them. Because I have both a 2 and a y in here, we have to take the fourth to both parts. So this would become a 2 to what power? 20th. And a y to the 12th. Now 2 to the 20th, you are free to simplify that, but if you try plugging that in a calculator, it is a massive number. So if it's something really big like that, we'll just leave it as in exponential form. If it's like 2 to the 3rd, we could go ahead and change that to an 8. So this one is fine. D, we have to take this square to how many different things?
You have to take the square to 3 at the 8th, cubed out of the b at the c.
Exactly, so I have to go to all of them. Now, this 3 is a negative. If you have a negative 3 squared, that means negative 3 times negative 3. What does it become?
Positive 9.
Positive 9, good. A to the
6
over b to the
squared.
and c to the good. Because this is a b to the first, and 1 times 2 is 2. If you ever get confused on a problem, you can write out, what does a square really mean? Yeah, we have this thing times itself. So if it made more sense for you to write this twice and multiply it, you certainly can. Exponents rules are kind of a shortcut for us to think about it, but it's not the only way you can get there. Okay? If it helps you to write it out, you can certainly look at it that way. Questions for me? I'm going to put the next slide. I have several examples on here. They're all very similar. Kind of see if I can stump anybody. Take a second and write down what you think the answer is for all of these. Because what is anything to the 0 power? 1. That was one of our properties. So 8 to the 0, 1. Right. B and C, what is the difference between those two? The parentheses. Exponents only touch what is directly in front of them. Okay. So in part C, this 0 is touching the entire parentheses, so the entire thing becomes 1. On this one, the 0 is only touching that 8. So the 8 to the 0 is 1, but what happens with this negative in front? It stays, so it's a negative 1. So if that negative is not in the parentheses, it's just going to trail down. All right, D. You can't just say off the bat 2 negatives make a positive, because order of operations, where do we have to begin? Yeah, let's start with that exponent. So this negative out front stays, and negative 8 to the 0 becomes 1. So that whole thing becomes negative 1. So the negative out in front just stays with it. And E, the entire thing is in parentheses, so the entire thing becomes 1. Alright, so I put this one on here just to refresh your memory. If there's a negative out in front, not included in parentheses, it just trails down. Any questions about exponents? Let's go back to our definitions. So, some terms on here, I am not going to have a definition section on the test or anything like that. I'm not going to ask you to write these definitions, but these are words that you're going to hear me say, so you need to know what I'm talking about. So, when I'm talking about an expression, basically, an expression does not have an equal sign. So you can have addition, subtraction, multiplication, division, exponents, all that stuff, but there's no equal to. The terms are separated by addition and subtractions. So a term could just be a single number. So I could say 5 is a term. It can also be a product of a constant and a variable. So 5x is a term. 5x squared, y to the third, z is a single term, because all of that is multiplied together. But as soon as you add in the addition or subtraction, you then have multiple terms. So terms are separated by addition and subtraction signs. And as we go through this year, it's going to be important for us to be able to look at something and figure out how many terms it has. So we're just looking for the addition, subtraction, separates those, breaks them apart. If I talk about like terms, what's that mean?
Terms that can be added.
Right, the things that can be added together. And in order to be able to combine them, you have to have same variables with the same exponents. So like terms are just two monomials. Do you guys know what monomial means? One term. So no addition or subtraction, just a single term by itself. So like terms are ones that can be added together, which means same variable, same powers. So monomial is one term. Give me an example of a monomial. 5. Yeah? Give me another. 3x squared. Those are monomials. All right. Give me an example of a binomial. What would be a binomial?
5x plus 2.
3x squared minus y. You have an addition or subtraction, breaking apart a couple terms. Give me a trinomial.
4x plus 6y minus 2.
Yeah. ladies, I know it is super cold to sit by that air conditioner, so if you want to move tomorrow, you're welcome to do so. Unfortunately, the front of the room gets really hot if I turn it off, so that's the cold corner. For anybody that's hot natured, that's where you want to be. We are only dealing with polynomials so right now, and so all of our exponents are going to be whole numbers. Whole numbers are like your 1, 2, 3, 4. No negatives, no fractions, decimals. So we're dealing with nice exponents at the moment. So all of these are examples of polynomials. A polynomial is just when you are adding together a bunch of those terms with those nice exponents. If I say a coefficient, what am I talking about with a coefficient? Like if I said 5x squared y, what's the coefficient? 5. It's just a number in front, the number it's being multiplied by. The really important ones that we will use a lot are degrees. And I will probably give you this definition at least 3 to 4 times throughout the year because it comes up. The degree is the exponent. So if I said 5x cubed, what is my degree? 3. A degree is like saying how many variables are in it. So if I just said 5, how many variables are in that? Is 5 a variable?
No.
So how many variables do we have? 0. So if it's just a number, the degree is 0. There is no variable with it. If I said 5x, your degree would be 1. If I said 5x to the third y squared z, degree is like how many variables? This term has 3 x's, 2 y's, and 1 z. So what is my degree? Yep. So all together in that term we have 6. And then in a polynomial, when you have a lot of these things added together, the degree is just the biggest one. So let's look at a couple examples with those. In this first one, if I ask for the degree of this polynomial, we have to look at each term. So the first term, how many variables does it have?
2 variables.
Well, it has 2 different variables, but if we think about the exponents as well, it has 3 x's and 2 y's. So altogether, that would be 5 variables. This one would be 4. This would be 2. We take the biggest. So the biggest would be 5. So when they're multiplied, you add it all together, but when you're looking at the individual terms, you just give me the highest term. What about this one? What's the first term? How many does it have?
2.
The second term?
2.
The last term.
8.
So my degree would be 8. Any questions, issues so far? I only have about 3 minutes left, so I'm going to stop today. Tomorrow we're just going to probably do some addition, subtraction, multiplication with these polynomials.